Hey, good morning.
Howdy. Hello,
Hello.
Alex.
Hi.
Howdy.
Hi, Ricardo.
Hey, Alex. Thanks for joining. I'm gonna give a little bit of time, maybe like another 2 minutes for some other folks to join.
For sure.
Then we can get
Yeah,
started.
thanks for inviting us to talk today.
Yep, for sure. All right, I think we can get started. Well, thanks again. Thanks for joining. Excited to have you and learn more about the Udycraft project. This meeting is actually recorded and we'll post it on the CNCF TAG-Runtime channel afterward. So for other people who want to watch it, you can just link it to that meeting, or people, just interested in the project could also refer to that. So with that, take it away.
Sure. Yeah, so again, thank you for inviting us to speak today. Today we'll be talking about Udycraft. I have presented got a presentation ready that I can share with you. I want to check if you can see my screen.
Yep.
Okay, cool.
All is good.
Brilliant. Okay, so with that, today I'd like to talk about Udycraft. It's an open source, secure, fast unikernel development kit. And so today's presentation will give a little bit of background as to what Udycraft is, how it works, and also a bit of a background as to us as an open source project. And so sort of where we came from, what we do, how we engage as an open source community. Yeah, so with that, I'll get started. And today also joining me, other core maintainer, Razvan, who's sort of overseeing a lot of the community as well. So we'll sort of be speaking together about different parts of this presentation. So yeah, the presentation is about what is Udycraft as software, what is Udycraft for people, a little bit of history, inception, its current state, and also a little bit about how we think the future of Udycraft will develop over the next year or so. So Udycraft aims to solve a problem that exists today in large infrastructure deployments, and that is the monolithic cloud. Right? If you think about your application that is typically deployed to the cloud, if you sort of zoom in and you scale into it, you have so your app, such as Nginx, and that sits on top of a full operating system and kernel, a monolithic structure that has system libraries, system services, things that are running in tandem. And so the problem here actually is that there are many unused services and libraries and parts of the operating system that exist when you actually run that deployment. If you think about a typical deployment in the cloud, you're usually running SSH, for example, or some additional services that might not necessarily be useful for the application, but are typically deployed there because this is what is familiar. This is kind of the infrastructure fabric. This is what is offered. The second is the security concerns that come as a result. So if you think about containers today are receiving many new CVE threats, many new security concerns. The ultimate problem is that the trusted compute base is the general purpose kernel that's underneath. It's a larger threat model. So the kernel is attacked in different vectors, which ultimately compromise the integrity of your application, because that's sort of sitting on top of it, right? So, I mean, there's a number of different ways around this, of course. You slim down your container, you slim down your kernel, but this isn't always necessarily possible, right? And there's always some ways to kind of shortcut the circuits there. For example, Cube system pods, they're within their own namespace, but they're usually just separated by this namespace. This is OS level virtualization. This OS level virtualization, of course, is only separating your actual deployed applications, but of course, system critical services are running next to it. Another use case of Udycraft is the resource scarce edge. So if you think about LTE towers, they have miniature data centers, right? They're usually resource constricted, and so Udycraft aims to enable more workloads on this edge. So I'd like to show you this performance graph that we did of a comparison of Udycraft versus a number of other key technologies, other unikernel implementations, but of course also here we have Linux, running as a native user space application. We also have Docker, which is just an OS runtime that then facilitates the application as a user process. And we run a comparison, and Udycraft ultimately has greater performance because it is tackling the problem of performance. The same goes for memory usage. For example, this is just another metric that I'm using. If you compare it against similar technologies that are enabling a runtime, it's using a lot less resources. And the same goes for disk space, for example. We're using less of, we're removing these services. And so Udycraft compared to, for example, a Docker OCI image or Nginx is an order of magnitude smaller. So with this, I'd like to explain how this process is possible with Udycraft. And so with Udycraft, we took a step back and we looked at the full stack of what is typically deployed today. So if you look at this sort of layered approach where you have your application, it's dependent on third-party libraries that are running on top of an operating system. These third-party libraries are like shared object files, for example. Then the operating system has libraries in itself, or glib, C. It has other services that are running, and then on top of this, it's usually for example, a flavor of Linux that facilitates the operating system. But then there's a monolithic kernel that sits on top. So this will have internal component structures that are necessary for the application, but some that are of course not necessary. You can think of those, for example, as like drivers, or to do with the file system, or with physical hardware peripherals, for example. So we took a step back and we looked at this full stack, and we realized, of course, there are parts that are not necessary for your application to run, but it's also very difficult to remove the bits that are not necessary. So can we librarize this process? And so Udycraft, as an open source project, aims to accomplish this goal of librarization of the full stack model. So where we have core kernel components and we have core OS components, and of course, libraries that are necessary for the application, can we build a structure and an API and a system that enables us to sew only the parts that are necessary together to create the final application? This is what Udycraft as a build system and as an open source tool enables to do. So Udycraft's core is a makefile kconfig system similar to Linux. So it's very familiar for those who are building at this level. But then it goes through a process of selecting the right libraries, whether they're low-level OS components or kernel components, whether they're third-party libraries or whether they're necessary for the application. This is then facilitated through command line companion tools that we offer as an open source project such as Craft, which allow you to quickly and easily select these parts. And the ultimate result is a bespoke, in this case, virtual machine that then has only necessary components, libraries, code, ultimately, that make up your application that is a virtual machine. When we think of this unikernel approach, it boots straight to application main. There's nothing else running alongside it other than your application. There's no SSH, there are no other system services. And as a result, also, we can do another series of optimizations because we're now linking at this layer. So, for example, one of the properties of a unikernel is that a typical syscall, which is usually a guard between user space and kernel space, is now just a function call. So the function call has obviously a lot less CPU cycles that are run to check various permissions, right? system capabilities, whether you are allowed to run or edit the file, for example, these guards are no longer there, and there's also no longer a context switch in some cases as well. So there's just an order of magnitude performance benefit when packaging your application in this manner. This is an example of a bit of a higher level stack. So here we have a typical Kubernetes cluster. So this is the example I gave before about where we have all the different components that are running to facilitate your application. We think about the container runtime. It is sitting as a level in between multiple series of abstractions that are ultimately enabling the application to run. So this is obviously one of the reasons for decreased performance compared to running things as unikernel. And again, there's also the security concern where your important system processes are mingling essentially on the same runtime compared to the application that you are running on your Kubernetes cluster. So with Udycraft, we are growing as a community, and we are trying to integrate with more systems that are actually in the cloud native space. For example, releasing a containerd plugin that enables you to run Udycraft unikernels once they're constructed via Kubernetes through a containerd plugin. I'm working directly with some engineers at K3S at SUSE to be able to integrate this into K3OS. Prometheus exporting, you think about a unikernel, it's now this tight virtual machine, well-packed, a library that enables the exporting of the metrics as possible with the Prometheus exporter that we have, libprometheus. And then, of course, tooling is also necessarily important, making sure that it is actually, I think there's a standpoint in the community like, oh my gosh, we're dealing with the kernel, we're dealing with low-level libraries and all this kind of stuff. Is it, I can't do this. I mean, I certainly was in this position a few years ago, but making it easy to use the tooling that we provide, we have a command line companion tool Craft that allows you to quickly, easily select the bits that you need in a fashion that is very familiar to the developer workflow. Then, of course, we're also adding other types of integration, like making it easy to build unikernels. For example, we have a VS Code integration that you can install, and then you can very easily add and edit. You're building your typical application, whether that's a Lambda function, whether that's something written in a higher level language. You can then very easily use this library, this extension, to be able to help you build a unikernel. We also have a documentation side. So this is, as I move towards in the topic of community and who we are as an open source project, we have a documentation site that's getting a lot of traction recently. People are using it. We're getting continuously updates to guides and tutorials and features, of course. I'd like to show you more of this maybe for a later date. And then we, as a community, often try and appear in lots of open source events. So we've been appearing at FOSDEM for the last few years. I think every time when FOSDEM happens now, it's like early February, is it? We have a release to commemorate sort of as a tradition now. And we meet with other microkernel developers or the people who are in the community there, working with unikernels.
A question. Can I interrupt you for a second to ask a question?
Yes.
Yeah. So you mentioned that, for example, your VS Code extension, some folks have Lambda functions.
Yeah, sure.
I mean, like Lambda functions converted to a unikernel, or to possible to run on a unikernel, or?
So a Lambda function is a great use case for a unikernel. It's a lightweight, very well-defined application, essentially, that has its purpose and gets some of the benefits from some of the properties of the unikernel. For example, this fast boot time. So I showed you, throughput with Nginx before, but there's also boot time. So you can experience a boot time of milliseconds as a virtual machine, right? As opposed to launching it compared to just a container, which the container initialization process is to go through. So packaging it as a Lambda function can make sense, and it doesn't matter really the language actually. So whether you're building a Lambda function in JavaScript or in Go. The JavaScript runtime can run on Udycraft, and we can optimize then even further, right? If you're not using all of the JavaScript runtime, you can just use the parse that are necessary for your Lambda function, for example.
Yeah.
And then, of course, you can just map that. There's a number of different ways that we can map, and we're building more ways that can map, for example, a HTTP REST API endpoint to the instantiation of a Lambda endpoint. For example, we have been working on making it possible. So this container D runtime that I spoke to you about before, we've been trying to port it, or we have ported it, and we've been doing some experiments internally at least. We're bringing it to OpenFAS. So OpenFAS, the Open Functions as a Service platform, where you can then map, for example, a Python Lambda function to this REST API endpoint, and then it boots obviously in a number of milliseconds, able to serve with a request.
That's cool. And basically, the Udycraft tooling will allow you to package this up, like even allow you to say if you're using parts of the JavaScript runtime, would allow you to trim down the JavaScript runtime or the Go runtime, or that's not there yet.
Yes, absolutely. So the JavaScript runtime V8, the Python runtime, all of these if you build them from source, they're highly modular in themselves. You can then pick which internal functions you would like, whether and so the Udycraft system sort of sits on top of that. And so you can then be like, oh, I'm not using these libraries, I'm not using these libraries. I can just then build a very specific unikernel for that Lambda function. And we will also ourselves try and build lots of permutations of these different runtimes, so you don't actually have to build them. We'll try and cache them, for example. This is through our command line client. But it is one way, for example. This is something I think that you don't necessarily get. I think it's interesting because you don't necessarily get this kind of opportunity to customize the V8 runtime or your Python runtime. You just, apt-get install Python 3, and then there you go, you get the version, and that's what you care about. But you can then pick and choose all different types of modules whether you want them or not.
Makes sense. So also, do you require KVM to be running on, say, like a virtual machine? So do you need nested virtualization, or you don't? Or
yes and no. So you can do nested virtualization, of course, and Udycraft ultimately does target a virtualization platform, of which there are several that are well supported already. So KVM, of course, Zen historically, because we are a part of the Zen project, Linux Foundation, we support this natively. But then, of course, there are more emerging runtime platforms such as Firecracker, which we support, or MicroVM. So any of these runtimes, of course, we can facilitate Udycraft. And the way it's built actually is that there's an abstract API for a platform, and we just, as use cases come in, and as the community grows, then they're being added continuously.
Yeah, but like say on Amazon, right? So if I have say, I looked at your project, so I was trying to build a unikernel, but like it seems like you can only like build or launch an instance, the unikernel, right? But like if you previously launched an instance, you cannot run it because that will be nested virtualization, and that actually is not supported by AWS or unless it's a bare metal machine. Is that right?
So yeah. So if nested virtualization, of course, is not enabled, then of course it's not possible. But at the same time, you can also build your Udycraft unikernel to support or to target AWS. So it would be an AMI image. It would then run as an EC2 instance by itself.
Got it. Yeah, no, that makes sense. All right, thanks.
No worries. Okay, where was I? Yeah, so just kind of showing off here some of the different ways we're trying to engage with the wider community, doing KubeCon talks or other talks.
One more question. Sorry to interrupt. Yeah,
Sure.
so if you go back to the FOSDEM talk that you had this year in February, I see the title says debugging and monitoring in Udycraft. So what are some of the things that you have for debugging, like in production type of environments? I mean, this
Sure.
is something that has actually come up a lot with unikernels.
Mhm,
So
yeah,
it's great to hear
this is
some of the stuff that you've done.
of course. So yeah, I think the big get the word now, but like the concern that people do have with unikernels is that it is very difficult to debug. But this has been an emphasis to try and ease with the Udycraft project. So one of the libraries that you can select, that you can build with Udycraft, is an internal GDB server. So you can then hook in to it once you open up, use GDB in the exact same way. You launch your GDB in the path to your kernel, and then you just attach to the port that it's now exposing, and then you can hop in and jump right through between your application and then straight into kernel components. You can see like where memory allocations are being done, for example. So the whole process is no different from how you would debug these types of applications. If you're running it in Go or in C or something like this. This is the workflow is very simple and very similar.
But in terms of log files, like if you want to, like if your application is crashing, those log files are being sent to the unikernel. It's I mean the contain package, or they're being sent to the outside.
So it depends ultimately on your what you're wanting to log. So Udycraft obviously as a kernel makes its own internal logs, and you can enable those and you can turn them on. They would be then sent to a serial port, for example, is one way, and you would just save your virtual machine manager is saving those to a file, then you'll access those for a file. You can also then attach for application runtimes. Maybe your application is making logging, then this would be then saved to the file system if you attach a file system. So you can do, if you ever done like Docker run -v, you can attach a volume in a very similar way. It just goes through kind of a different protocol called 9PFS. And then it would just save those files in the same place. There are other ways to attach, of course, a file system to Udycraft. You can also send things to standard out, and then it's just how you then configure the way that you've instantiated it with the virtual machine manager. Then everything from the kernel logs to application logs would be mingled.
Makes sense. And a follow-on question would be, so you're working with containerd at the same time, so this would be actually interface with containerd, so you could run potentially this in Kubernetes.
Yes, absolutely. So we're planning on open sourcing this this month. So in the next few weeks, we'll be making a release where we have a lot more documentation, and we show off the containerd integration. So this is facilitated through a plugin. This plugin changes the runtime class. So you just, when you launch your do CTR or whatever, or whether that's through Docker, you just change the runtime class, and then it launches, given that there's a virtual given KVM or whatever hypervisor can then launch the Udycraft this way, but it would show up looking exactly like the container would look like. So it would look exactly the same, be mingled. Then you can then still see the logs this way. So if you're looking, do Docker logs follow, they would be appearing there. It would attach to the same network interfaces, for example. And then one of the other things that we'll be showing is that the image is, so containerd, or the whole ecosystem relies on the definitions by OCI. So the image spec, the runtime spec, and we sort of adhere to this using the edge container interface, I think is called, the ECI. So this is Linux Foundation Edge. They've created a spec that's based on top of OCI, and they basically say, at this path is the kernel, at this path is the init RAM, at this path is other stuff, file system things that you might want. And by interfacing with that, we can then have transport enabled through OCI archive. So pushing a unikernel inside an OCI archive to Harbor makes perfect sense of this. It's able to accept it, able to see it. But we're working to try and make that integration better. So this is also part of the conversation I'd like to have with you today, is about how we can make this integration a little bit better. Because of course, if you put, we ran a hardware instance, we then pushed this ECI archive to it and didn't really recognize everything that was there. And so like making these contributions for better support is something that we're working towards.
Great, makes sense.
Yeah, we also have Google Summer of Code. This is led by Razvan at the moment, who we have a number of students and student projects that are contributing for libraries or improvements to the Udycraft core. So this is, okay, now I'd like to start a little bit talking about the community. Maybe Razvan, if you want to talk about our community.
Yeah, for sure. So regarding a bit about GSOC, there are 3 students who are now working. They are doing very good work, and the very nice thing is they are also going to be part of the community. We've involved them into some other tracks, so it's kind of a nice way of getting enthusiastic students on board. Yeah, about the community, this has been growing during the past year. So you can have there the link. We started the governance model. Everything is now happening on Discord. For I think a bunch 2 years ago we were using Mattermost. It was a bit more difficult, but now we have a full Discord there. How many people were there yesterday? 400 or something, Alex? We're getting close to 500. Yeah, so we're getting close to 500 students on people on Discord. It's a growing community, and we are using mostly open source tools, so Discord, GitHub issues for this. During the past year, we started organizing more. So that happened on, I would say, on 2 layers. One layer is let's say the staff, the actual people contributing, and the other one is projects and tracks. So on the first side, we now have this kind of maintainers. We now have community leaders, as we call them, so people who are in charge of the release, the CI/CD system, GitHub, and documentation and blog posts. And also each track as part of the roadmap is assigned an owner and a tech lead to make sure that this happens in time. This has been backed by, and this is mostly Alex's work, adding GitHub-based projects and tracking all these activities, making nice use on them, and making sure we keep good track of what's happening and by which time. I would say one of the important items here is that about a year ago, we switched to a more frequent release model to make things, to make developers fill out their work in a consistent manner. And I think we started on December or November last year. We are now doing a once every 2 months release cycle. So that means that we are doing a release each of the once every time. Yeah, you can see here V09, V08, V07. These are the releases that we are currently planning, and we are basically allocating PRs and contributions for people to happen in as part of these releases, and then these go on via GitHub. So I would say during the past years we did a lot of evolution in terms of organizing the community and also organizing our tracks. Yeah, Alex.
Yeah, I just wanted to show that we're constantly tracking all the stuff, and there's a lot of activity on our repo at the moment. I go to my pull requests. It's all kind of automated as well, like how the PRs are managed, and who becomes an assignee is like a maintainer who like guides the PR into a workable shape.
Alex, maybe you can show here the team management, so the way we have organized the teams into special interest groups and the reviewers and maintainers subside of those.
Yeah, so we have this governance model here, where it's like this repository that's it's a CI/CD step actually, And then we have like teams. These are special interest groups. So we've got like people who are interested in certain parts of the kernel or in different kind of projects. So we'll have people who are like interested in the API. You are listed a maintainer here, and there's like reviewers, and then it's just a case of like electing yourself through a PR, and then you vote to become a member of, just by adding yourself into this list. And then this is synced, and then you're automatically assigned to the different parts of the code changes, for example. So like here we have like time, and then our bot will automatically assign someone. So Cesar and yourself will assign depending on this allocation here. And then, yeah.
So something I will also point out, Alex, you can maybe go to the repo. So we have community gatherings. So we have weekly meetings. Maybe Alex, you can go to the repo, the meeting notes repo, just to give a highlight of how everything is stored. So we have this repo where we are storing all meeting notes for. So we have community. The discussions are split into topics of interest. So you can see there the community meetings, and then specific topics. We have GSOC, we have maintainers meetings. All of these are stored here, so you can get once every week or once every 2 weeks when there's something happening. Also, we are doing each Saturday, there's a 4-hour hackathon. There's also in the meeting notes a note on them. So we interact on Discord. It's online. Me as an academic, I also gather with some students here at the university, and we work on these topics. And also we are, it's actually now we are under deploying what we call Udycraft Summer of Code. This is a 10 days hackathon, 10 days workshop. It's happening online. This is the second edition. So this is happening yearly, and we get more people involved into Unikernels, Udycraft, and everything around that. If you look here in hackathons, so this Udycraft Summer of Code, this is the current hackathon. So it's a 10 days one. This is the schedule for it. It's going to end with an actual hackathon on Saturday. And based on the kind of the content that we develop here, it's very valuable to understand how Unikernels work and how Udycraft works. If you see on the left, we have scheduled different hackathons. We had one in Lyon, one in Hacken. It's one planned for Munich in October this year, and we are discussing to organize one in Karlsruhe and one in Manchester sometime in November, December, or January next year. And there are also discussion to organize a nation hackathon. So we are kind of actively looking in university partners to kind of spread the word more about operating systems, Unikernels, and Udycraft.
Yeah, this is great. One question that I have is, so you have about 70 contributors, is that so are these contributors coming from mostly different companies or different universities, or where they?
I would say both. I would say both.
Okay.
Yeah, it's definitely a mixture of students who are interested in the technology, and then there's also like industrial people who come from industry who using Udycraft and are they found a bug, or they wanting to learn if there's like going to be support for something in the future, or looking to debug something through a support channel or something like this.
Yeah.
And then we have a number of paired like stronger collaborations of partners. Actually, I think I have a slide on this. Oh yeah, so I think there's the wrong order here. Yeah, so we're pairing with a number of different partners and collaborators, right? Where we continuously meet with them, and they join the maintainers pool or the regular contributor pools, or they've contributed very significant parts. So like Open Synergy and ARM, they've really driven a lot of the ARM development. So a lot of new security features that are coming out on newer processors or specific use cases. They're building those.
Nice.
And then of course, like
do you have any end users right now? Any people that are these companies using them besides contributing?
Yeah, we have a list of people who are using Udycraft in production. I don't have this list on me at the moment, but we do know that there are people using it. and we're working with some of them as well.
Got it.
To like make
Yeah,
it
so
better or like
yeah, so I think you're applying for a sandbox in the CNCF right now, and so just something to keep in mind when you start applying for the next levels, like incubation. You might wanna, like think about some end users. They're some of the better ones because they basically, the TOC and the CNCF goes through like a due diligence process, and they talk to them, these end users, and ask them questions about how the project is doing for them, what it's doing for them, and how they're running it, and whether they're running it in production. So those are some of the typical questions that come up, right? But just a word of advice, right?
Okay, right. So this is kind of brings us to the last slide of this presentation, where it's like we are hoping to start this conversation with you at the runtime group about applying for Sandbox, about what this process looks like, about how we can start to better make this integration, if this relationship makes sense, and because we see Udycraft as like this, it's a way to optimize what is, a very diverse sort of playground of tools and services that are being deployed on the cloud today. So there's lots of services, and I think Udycraft can offer an opportunity to be a runtime model that allows for optimization, allows for better security, given some of the constraints that we're seeing today. And towards that, I think a lot of the community aspects, governance, potential collaborations with existing projects is something that we're looking to try and strive and push. So sort of any feedback that you have, any insights that you can think of, and guidance that you could provide to us would be super beneficial.
Yeah, so I think it looks really good in terms of the community. I mean, you have a lot of contributors. There are projects that have a lot less in terms of like, number of contributors and number of commits, and also maturity. So like the project seems fairly mature. I mean, you already said that you have some users running it in production, so that's really like a good sign. So I don't see any roadblocks in terms of Sandbox. So for the like incubation stage, I think you might want to like think about how do you get more exposures to end users, and basically evangelize that in the community. So the process is like a TOC member steps in and decides to sponsor the project. So you need to have enough information there, and open once you go into incubation, you open a GitHub issue in the TOC repository in the CNCF, and the process starts from there. But in my opinion, it looks pretty good, right? So.
Okay, brilliant. So I think so I went through some of the TOC documentation you had on GitHub. So I think just from this process, we'll submit a PR, as I believe, that creates a new document on the TAG-Runtime or the TOC about a Sandbox project. I think there's a first step.
No, I think for the Sandbox project, it's not even a PR. I think it's just a spreadsheet. You can read about it, right? But right now the PR is more of for incubation. But yeah, you can read about it, and if you have any questions, I'm happy to help you and guide you through it, right? So I mean, in any case, we can contact some of the TOC members too, so if we have any other questions.
Okay, great, sounds good. I'll stop presenting here, I think.
I have another question. So it's the project mainly backed. Is it a company called Udycraft, and the project is being backed by Udycraft as a company? Okay, yeah.
Yes, that's right. Yes, but that doesn't mean that. So Udycraft as a company offers a number of different support models on top of Udycraft.
Got it.
But as a project, we are open core, following the sort of commercial open source.
So one of the things that comes up sometimes with the incubation is the maintainer diversity, right? So like if Udycraft is just the whatever 90% of the code maintainer, that there might be concerns, right? Because they want like other companies also in case Udycraft doesn't
makes total sense.
Yeah.
This is kind of also like we came from this open source background, with partners in industry and academia. So I find that most of the support comes from the wider community. It's just in some cases where there are really bespoke things that are required that come from Udycraft as a company. This is the kind of model that we're at the moment.
Sounds great. One last question. Have you heard of this company called Contain? KONTAIN, Contain.app or something? It seems like they're actually working on something similar. So maybe just something to
scalable and secure microservices. This is the contain.app as a website.
Yeah, exactly. So they're working on some unicorn stuff. So I just want to keep an eye on.
Well, we'll have a look.
I mean, I think they were doing some open source stuff, but I'm not really sure. But
from what I see from GitHub, it says it's compatible with containers. Yeah, okay. I'm not sure if they are using unikernels behind the scenes.
Yeah, they're using unikernels. So I talked to some of the people there, and they were actually trying to make unikernels more developer friendly, right? So that's and to make it more such a behaved more like containers, right? But I think you're already doing that, right? So like, I mean, you're OCI compliant.
We're doing exactly this kind of work already.
Okay.
Cool.
Timothy mentioned on the chat that he had some questions.
Yeah, sure.
Yeah, if you don't mind, Tim Middlecoop, Internet 2 Research Engagement. These questions come from the perspective of research, computing, and data professionals that support researchers. So their applications are a little bit different than microkernels and services and things like that. There is a move, as you may know, to a lot of researchers starting to use some of these non-HPC systems. So my question is from the perspective of somebody that needs to support these applications, so not necessarily the end user, but somebody that runs a cluster to bring these apps up. So there's usually a number of popular applications. How manual is the process? Like how long would it take to bring up an application? How difficult is it to bring up an application to run on the unikernel?
So is it bring as in port or bring as in instantiate?
As in port, right? So let's say I have Gaussian or something like that, which is sort of another question I have is like, it's a binary commercial package, right?
Sure.
Very well, very unbehaving at times. How long would it take, or what's the effort to take to port that?
So Udycraft aims to be completely POSIX compatible. POSIX, I mean, today is a loose term, but largely completely Linux compatible, which means we support all the same syscalls. So if your application is built against for Linux, then it is technically completely possible to be able to run this binary sort of on top of Udycraft. It's still compiled. There's just jump instructions now wherever syscalls sort of are represented.
And so how difficult would that be? Would that be like an afternoon? Would that be a 6-month process? It might be technically possible, but if you have to enumerate every single syscall in the program through a debugger, that might be a little bit difficult. Just a typical binary, how long would that take?
I don't think it's a very hard process. Razvan, you have some experience doing this.
So I will start from the end. For the binary compatibility side, for the binary side, we actually have a layer, we call it binary compatibility, and I actually been working on that during the past month, where we would be able to run unmodified Linux binaries on top of Udycraft. So this is happening. There's kind of ongoing work to make it work for dynamic executables. Currently, it works for static Pi executables, but it shouldn't be that much time to get it working. So Udycraft is designed, as Alex mentioned, to have this POSIX compatible interface. And there's something that we call the syscall shim layer that allows you to run this unmodified binaries on top of Udycraft. Of course, this means that you are going to run them as they are, so they aren't going to be tightly coupled to the way Linux or Udycraft works. You have to trampoline via the syscalls that the application makes to Udycraft. That's one thing. The other thing for porting the application, there is ongoing effort, and the aim is to have it complete sometime in the next 1 or 2 weeks to add muscle support. Muscle is this kind of quite complete POSIX standard C library that's going to be integrated in Udycraft. And once that is done, the aim is to have what we call auto porting. So by that we mean you would be able to build the video application against muscle, and muscle itself is going to be linked with Udycraft, and that says that with minimal updates you would be able to get your application working on top of Udycraft. So from my point of view, it's talking about maybe days, at most 1 week of porting time once muscle is enabled. Then of course the most important part is going to be to fine-tune your application to truly benefit from Udycraft's configurability, to make it as potent and performant as you want.
Gotcha. Now, in your experience, how these applications are really usually computationally bound. What kind of speed ups and improvements do you see for computationally bound applications?
I think I think Alex can fill me up on that. I think for computationally bound, not so much from my understanding. There is no SMP support, so if you want to parallelize, that would be available. I think most of the benefits are going to go in those applications where you would actually have a large chunk of time usually spent in kernel space, because user space, application space is going to be mostly unmodified Udycraft versus Linux or anything. But if you have significant time spent in kernel mode, then that would be improved by running on Udycraft. And there's some work being done, if I recall, on Nginx that's able to convert those times into better performance with Udycraft.
Okay, yeah, your answers to me. Sorry, go ahead.
It's like IO bound, really.
Yeah, IO bound, yeah. I mean, networking is one area in we need to work, particularly looking for increasing the performance of the application.
So in other words, things that have a lot of context switches between the kernel and user space could benefit from.
Yeah, for sure.
Okay. So sort of one last question in binary space. What about the elephant in the room, Nvidia GPU Cuda support? Is that reasonable to have a Cuda application?
We talked about, yeah, Alex, yeah.
There was some researchers on a small company in the UK, Focus, that built a driver for Udycraft to interface directly with a Jetson Nano. So they're able to directly interface with the GPU. So you can do GPU offloading via Udycraft, for example. And that, we have not been focusing on so much. It's kind of they've been driving this work, but it shows that it is possible to do things like this.
That sounds like it's using the GPUs natively, not using that entire Nvidia Cuda stack and all the libraries that go around with that.
Yeah, this is called VXL, as far as I understand. Yeah.
Cool. Sounds like a really fun project. So thanks for giving me a little bit more perspective on where it sits in the trade-off between performance and difficulty of actually getting that performance.
Sure. Yeah, I think one of our main goals is to try and make it as easy and as compatible as possible, right? Because you do get these performance benefits and you do get these security benefits. And so looking at the different ways people are building applications, of course, there's lots of different ways. Everything from like a proprietary binary, which you cannot touch and you don't have the source code. And then like the blurriness all the way until you have the source code itself and you can do even further optimizations and shortcuts, for example.
So it sounds like if you own the complete stack, that's where it's going to be sort of the easiest and most powerful to do, and where the sweet
Yes.
spot is. And depending how far away you go to the binary, it'll get more difficult.
Yeah, that's kind of it. So it's kind of this palette of options, and we've done very good progress during the past year. My estimate is that maybe in some 2-3 months time, it should be fairly easy to port any application on top of Udycraft. And then, of course, the idea would be to custom tailor it with Udycraft to get the best performance out of it.
Gotcha. And so I guess on the worst side of the scale, an application that will only run on Ubuntu 16.04 would not be a good target for.
Not necessarily. I think if you, for example, if you have all of the shared libraries, and if you have whatever they are, plus your application binary, you can still package that together quite neatly in the unikernel model. Of course, there are going to be opportunities where you could have benefited from sewing them together because they're more inline. Maybe you have like a run to completion type application, and you don't have to switch between these different modes to get to the different libraries. That would benefit from sewing them together, of course.
Gotcha.
But that doesn't mean that you can't fully have. We can still like chop and change binary rewriting some of the calls.
So I got one big gotcha. There's no SMP support. Are there any other things that are there?
No,
like,
There is. I said now that we have SMP support, it was just enabled during the past releases. It first with ARM, and just weeks ago we open sourced the XCTC SMP support.
And the applications that use the standard P threads and stuff like that would work out of the box.
Yes. We have. Wait, what? We have P thread embedded, right? What do you mean? Sorry, can you repeat the question?
Well, you have SMP support enabled, but does it work like you would like it? Do you have to use a special library to actually enable it, or is it like P threads? Or
for the next release in about a month or so, we're going to be tying that into the default scheduler. So then any thread that's spawned in Udycraft can be offloaded to secondary cores.
Cool. So I guess there's a room for optimization there too, because since it doesn't have the Linux kernel scheduler, then you can tweak the scheduler.
Yeah, I mean,
how you want to do it.
The goal here is to be able to actually, you would be able to not only select your scheduler or your memory allocator, but you would be able to have multiple schedulers, multiple allocators, depending on your use case, and certain threads or certain parts would be using that, the other parts would be using those. So it's highly configurable. It depends on your use case, and then you would be able to fine tune what suits you best.
So in terms of applications for a researcher that's running an application that they're constantly banging their head against the Linux kernel, that would be a potential avenue to kind of make those problems go away.
For sure.
There's a built-in cooperative scheduler, and then what's the other scheduler? There's 2 schedulers built into Udycraft you can switch between. And then I think there's going to be a time-based scheduler that will be introduced.
I only know the cooperative one. I don't know, and maybe there are some other, but I know there's this. So there's this thin layer, and on top of the thin layer, we call the generic API. You have different implementations. So you have the allocator API, different allocators. You have the scheduler API, and then different schedulers that you can then select according to your needs.
Gotcha. Okay, thank you.
You can do the same also with memory allocators. So there's different memory allocator implementations, and then you can also attach different memory allocators to different schedulers. So you could have like, I mean, there's poor performance, but you can have a buddy allocator, or you can just have like a static region allocator. Or you can, there are different implementations of third-party schedulers, like Microsoft made one called memalloc, which performs very well. This has been
allocator, Alex. It says schedulers.
Yeah, no, I know, but you can attach that memory allocator to its own
scheduler. Yeah. And also networking stacks. There's now there's open source POSIX drivers, socket drivers. So if you a given family FINet or FINet 6, you can select a given network stack to handle those. So that's also available. Being able to select your implementation of the network
down to the lowest levels of the OS primitives, you can customize that a lot.
So an application to transfer large amounts of data potentially would be a potential use case as well. There's lots of folks that have 100 gig pipes to the internet here that they would love to saturate, and that becomes very difficult you have to pin cores and
Mhm.
all kinds of tunings in terms of trying to get those things to run at wire speed.
If you know, for example, your payloads, you can then customize the network stack to change like the TCP window size, for example. And then suddenly you get much higher bandwidth.
And I assume it's using the Linux TCP/IP stack. Is that correct?
The default one is LWIP, lightweight IP.
Oh, okay.
But and there's a number of it is possible to plug in other TCP/IP stacks, different implementations.
Okay. Cool.
Switching gears a little bit to have another comment. So I think there's an opportunity in the community to maybe drive the standards for unikernels. So one way to do it is, I mean, you could do this before or after you apply for Sandbox. You could actually create like a working group, like a unikernel working group that, you know, under the CNCF,
Yeah.
people can gather together and create standards around unikernels.
Mhm.
I mean, you could be the driver for this. I know a lot of there aren't a lot of places where people are gathering around creating one standard, kind of like OCI, right? But for
Mhm, mhm.
unikernels. So I think there's an opportunity there. So
Mhm.
I thought I'd bring it up.
Yeah, makes
it's
sense.
a great idea.
Our previous hackathon was in Aachen, and our host, Stefan Lankesh, he is the author of Rusty Hermit, which is a unikernel written in Rust. So it should be interesting to kind of gather people with unikernel interest and come up with this, let's say, set of conventions and maybe common interfaces for development or interaction.
We speak also regularly with some people at the Mirage OS community.
Mhm.
This is an OCaml unikernel project built straight into the OCaml tooling, so that you can build your OCaml project as unikernel. And I think, yeah, they've had a lot of ideas. I think, you know, Mirage OS is one of the very first unikernels, or at least the first to term the unikernel. So I think it would make a lot of sense to have a working group like this. I think it would be really interesting to have a community built on building ideas in this space.
Yep, just let me know and I can help you and just
That'd be
talk to me on
amazing, yeah.
Slack or you just ping me and we can make it
Okay,
happen.
perfect. Thank you. Great. Cool.
All right, looks like we're at the hour. So well, thank you very much for joining.
Thank you for
Timothy,
having us.
Timothy, do you have any last minute questions or?
No, I'm
Not
good.
that I can think of, actually. But yeah, it's a good experience. And yeah, no, I'll get back to you on the Sandbox application.
Sounds great. Alrighty,
Perfect. All right. Thank you for
Right.
taking the time. Have a good day.
you too. Thank you all.
Thank you so much. Bye-bye.
Bye.
Bye.